talking about here. We looked at the force, and the force was W, and the first thing we did is, can we figure out what the perpendicular distance is? And in that case, can we? Yes, it's 8. It was only when we couldn't figure out the perpendicular distance and we had to do geometry that we had to look at the x and y components. Okay? So, did everybody get 750 for the weight?
No.
Yeah.
Okay.
We're doing some of the moments about the origin.
About the origin, the 7.
Why wasn't it? Oh, that is the radius. It could be the radius.
Yeah.
Yeah.
So we get the W and we get mu. Santiago?
On equation number 2, how come you're factoring out that 0.866 even
Well,
though we
this
have
is-
already multiplied WC by 866?
Did you do the full equation? Let's write down the full equation. I'm just giving you my end result equation so you can check. So sum of the forces in the y, it's going to be n minus, y is there, it's going to be yw, the y component of w minus the y component of c, and that's the only thing, and it's equal to 0. So n minus, what's wy over there? Could you read it to me?
For
Eugene.
WY is
Eugenio.
negative 0.866 W.
W, okay, and then what's wy, cy?
Negative 216.5.
Oh, because I didn't, we plugged in the what, which one do we know?
WC.
We know WC, so this would be 250.
We know W.
We know this
This is 250, right?
Yeah.
So what was this one equal to? What's WCY, Santiago?
WCY negative 216.5.
Okay, equals 0. So what I just did is I left the 0.86 times WC in there. I didn't plug in the 250 yet. Right? And this equals 0, and then I can solve. Right? Same thing.
Yes.
Okay, so what is this telling us then? We're up to Uriah.
What is?
So when W is 750 pounds, what happens? Does it move?
No, but if it was just slightly more, it would move.
Okay, well, let's look at where W is.
Oh, so if it was slightly less, it would start rolling down the hill.
If it was slightly less, it would start rolling down the hill.
If it was more, it'd start rolling out, right?
No, it doesn't roll up. It would, well, it could roll up, but we're talking about sliding. Remember, we're talking about sliding, right? So if W was less than 750, it would start sliding. Okay? Now what if mu, it says mu is 0.577. So that means it's in static equilibrium, right? So talk to me about mu being less or greater. Enrique?
If mu was lesser, then it would start sliding down.
If it was lesser, it would start sliding. So why then are they calling mu minimum? Enrique?
Because I
So-
guess they're asking for the minimum amount of mu in order
Right.
to keep the cylinder in
To
equilibrium.
keep it in equilibrium. If mu is greater than 0.577, it's still going to stay there. I tend to get confused sometimes when they ask for a minimum and maximum. But just remember that you're calculating the value. So let's just say it again. Mu we got is 0.577. And we use static equilibrium equations, right? So when mu is 0.577, it's staying still. Does everybody agree with that? If mu is greater, is it staying still or moving? It's staying still, right? It's more friction, right? The greater the coefficient, the rougher the surface, right? It's gonna stay still. But if mu is less than 0.577, then what's gonna happen? It's gonna start sliding down. So then, would you call mu the minimum or the maximum for static equilibrium? The minimum. And why are they looking for minimum or maximum of statics? Because we're doing a statics problem. They're not looking for minimum or maximum of movement, because we're not analyzing movement. We're analyzing static equilibrium. So whenever they say minimum or maximum, we're talking about minimum or maximum for static equilibrium. Chelsea?
So what I don't understand is, couldn't we have different values, like a higher mu?
Yeah, we certainly can, and that's why, they're asking us for minimum and maximum. So let's look at W. Right now, we calculated a value of 750, and it's still going to stay there. If W was greater, what would happen?
Mu could be less.
Well, let's just keep let's keep one constant and increase one. If W is greater, if the weight put on the thing was greater than 750, would it move?
Yeah.
Let's say a little bit greater. It's not going to move. But if it's a lot greater, it might start to roll up. Okay? And you're going to look at those kind of problems when you get to dynamics and you start talking about motion. Because in the end, what's that law? F is equal to ma. Right now, we're dealing with no acceleration, right, and no motion at all. But when you get to statics, you have that extra part. So first you have to be comfortable with the statics part, and then you move on to dynamics. Okay?
So those values would be the minimum to keep this system in equilibrium?
That's correct. Because we're analyzing it for motion which way?
Going down?
Motion going down. We're analyzing for motion going down. So both W and mu would be the minimum for static equilibrium. What's interesting is I went on and I did it for movement upwards. I wanted to see what would happen. And in the end, there is no sliding upwards. It would only be rotating. So you actually get negative values. Would you guys like to see the math for that? I mean, I could copy that and send it to you.
Yeah.
Sure.
Yeah.
Okay. It basically shows you can really only analyze it with motion going down for statics. Okay, let's go to the next problem, because I'd like to look